All right, so this is one of the things that you're going to need to be aware of for SolidWorks. I'm going to provide you with that title block, and we're going to develop the title block a little bit more. I started with the my A size, and I made a few modifications to it. There's a few things I want to point out that will be useful to you in SolidWorks as we go further in if you want to develop some of these things. So one thing we need to do is under the File Explorer, the Windows File Explorer, we can go into View up on the screen. If it's not shown, you'll want to hit the little arrow over on the right, or just click on the pull down and it will show up if you need more screen space, which I kind of like to have the screen space. I'm not real fond, as mentioned, I'm not real fond of the item checkboxes. So if you turn that on, each of these will have a box next to it that you can check. I'm more of a select, control select, shift select preference. So I don't usually do the checkboxes. Extensions, so we can see the TXT, the SLD PRT, the SLD ASM, the SLD DRW. File extensions, those are kind of nice, so I would have those on. And then hidden items. And hidden items will show you program data, which is technically a hidden folder. It contains a lot of installed data from the various programs. So if you don't have the permissions for it, a lot of times it won't let you write to this folder. So we're going to try this both ways. All right, so once I get through modifying this sheet format, I'm going to upload it to Canvas for you so that you can pull it down and see some of the changes, see the things, and then also we're going to start using this, build it into our parts. So I may have to add on the custom properties. I'm going to do that in stages because, again, the expectation is that you're going to interact with SolidWorks, but the full SolidWorks class is kind of ahead of us, not really behind us. So anyway, this A landscape, I should be able to open it. I'm not entirely sure. Open. And if I come over to my downloads and just pick on it, it does open as an individual file. But where SolidWorks can find it, we're either going to have to browse or put it in a location. So one of the things that we do for the SolidWorks class is if we're going to create a location in the cloud, so Dropbox or OneDrive or even Google Drive, we're going to create a folder that's going to kind of take the place of some of the default Windows locations so that we can streamline this process of not having to look the 10 levels deep to find this piece. So let me point out where you're going to look real quick, and then we'll make some modifications and see what we can do with our existing drawing. So once you have program data shown, we can click on it. We'll come down to SolidWorks. SolidWorks 2018, language, English, and then sheet format, weldments, and properties are kind of the two folders and the important text file. Oh yeah, and this little gtol.sim, those are our geometric tolerances symbols. So when we start pointing things in different directions, we really don't want to lose track of those. So it's kind of a be careful, be aware that when we're making adjustments to the SolidWorks system, to that environment, that we're not getting too crazy starting to create these other problems. Under the sheet format, then the problem is that you have every sheet format for every standard. So the DIN, well, you name it, ANSI, the ISO, they're all in here. All right, so part of that problem is I'm not going to use 90% of these. So one of the advantages of adding another location for the sheet format is to kind of bypass this. So if we're not going to go through that process of creating, I still want to take the SLD DRT, which is the sheet format extension, and I want to copy it into this location so that it shows up in the list of usable items inside of SolidWorks. All right, so we'll get back to that once I provide it to you. So the modifications that I wanted to make were, I took the picture out because it was an older, it was the older icon for, or the logo for MCC. So we will, I think I have the new one. I'll see about inserting that one in. The third angle projection. So if I edit this sheet format, then I want to make this a block, and it is oversized because I drew it on one level, and when I transferred it to the other level, it popped up a little bit. So one of the advantages of making a block is that this will move as a group rather than individual items, and the scale is pretty good. I drew it kind of down here where it was supposed to be, and then didn't realize that when I took it over in the sheet format I had those slightly different scaling issues going on. So up in the upper middle I have a make block, and those are all the objects going into the block. And layout sketch, drag manipulator, how about we put it at the center? I thought I was doing both of those. Okay, that'll work. And then we'll go ahead and accept it. And then from there, when I move, I'm moving everything as a group. Now if we were to insert this, it would give me the option to scale it. So let's see if I can go back into the sketch and scale. And we're scaling about that insertion point. Oh, and entities to scale, we'll grab the whole block. Please change the scale of a block from its property manager. All right, so in the blocks, then now that I've created it, I can edit the block. And where are we finding that? Actually, I haven't done this in a while, so now I'm searching all of a sudden. So that should be the sketch. Let's see if it'll do the scale from here. All right, going to, give me another error, no. Okay, a little bit smaller, a little bit smaller. Yeah, it doesn't look too bad. Go with that one. All right, so we can jump out of the block, and then I can drag it. Oh, and I still missed by a little bit. So we're going to edit that block one more time. So on the right mouse button, then instead of coming over to the toolbar, I can edit the block. And let's see if it's going to include everything in that or grab some other stuff. All right, we can do that. And go back into the scale, and a little bit smaller yet. Oh, scale about would be nice. Oh, so it went 0.4 past the 0.4. So maybe not that much, 0.8. All right, so somewhere in there, since I'm just I'm playing. If I need to, I will adjust it. All right, so I have my do not scale drawing. I have my projection. I do not have the listing for the ANSI or the ASME Y14.5 2009. So that would be one of the notes. I have the drawn, and we have the standard tolerances though. So we're pretty much covered. See if I can find a spot for that. I do want to drop the logo back in. So really the unless otherwise specified, and then what is our favorite note? Let's see, we need to get back into the annotations and the notes, and per 14.5 and 2009. All right, so that's still pretty big. Let's see what it looks like as a 10 point. Oh, I guess it would help to have all of it. So Control A to grab everything in the window block. Yeah, we got all of those caps. All right, so I'm probably going to have to modify that, but that gets us started. And slide it in. And now I'm just being picky. All right, so we have that in place. That creates the background. That creates the sheet. And so if I were to just save that file, it's going to default over to a DRW, SLD DRW file. So I have to tell it that I'm creating a drawing template. Or the one that I always forget is the sheet formats come first under the file. Don't know why they're separate, but they are. So under File, we're going to save a sheet format, and I'm just going to overwrite the existing. Okay. And then if I close that out, no, I don't need to save because it's going to offer to save back to the drawing that I just was working in. All right, so the issue is that this title block fully takes up a third of our sheet, and so I would like to change that out. Let's do the experiment on the first sheet that was our assembly with the balloon callouts. So if I right-click and I go to my properties, and I don't see properties, so let's go to Customize menu, and I don't typically delete sheets here, but I do like to see the properties. So I can customize any of those menus as they come up. And if you're not getting to do that, we'll, following along, we'll take another look at it in lab. All right, so properties will take me into the sheet properties. And since I did not place it all the way down in program data and to this location, then I'm going to browse. And I'm going to see if this works. If I don't have to put it in into the sheet format location, if I can just open it and tell it to apply changes, I now have my sheet format. It becomes part of that group. So I can test this. I can work with it as the sheet format, and then come back later and create a drawing template, build it up from there. So I'm going to go ahead and do the others then. So properties, did it stay? No. So browse. And we have the select sheets to modify that I jumped over. So I want to say this was added in 2017. Oh yeah, the use custom property values for models shown in default. So same as sheet specified in document properties. I'm going to uncheck that. Well, maybe I'll leave it checked and we'll make sure it works first before I start pushing too many buttons. So let's select the sheets to modify. We already did sheet 1. I'm going to do 2, 3, 4, and 5 and apply changes. Can you use already existing blocks or rename? Do you want to rename? No. We'll just use the existing. And it's probably going to ask me that 4 times. All right, so basically once I create that block for the third angle projection, then it's going to say, are you overwriting or keeping it? All right, and then the last one would be for the properties. I think I pointed this out last time, but I'll point it out again, the type of projection, first angle or third angle. So we set that up as part of the template, as part of the sheet format, and then it comes in from then on in that type of projection. All right, so I'm going to pause here real quick and we'll upload. Okay, jump to the logo. Found the Mesa Community College, Maricopa Community College logo, and so I want to insert that into the sheet format now that I've changed it over to my drawing. The one I'm going to upload for you guys, I would like to be relatively complete. There'll probably be a few more changes, but you'll get to do those if we encounter them. So if I resize this, we have pixel count, 1030 pixels, and this is probably a fairly big, well, not too bad, 19 kilobytes. So one of the issues with any image that we place on a sheet format or a drawing template is that it accumulates on each page. So the first time I played with this and I had a nice 1 meg bitmap that was high resolution, looked so cool, and I shrank it down into the corner and I did a 20 page and went, wow, how did my drawing get to be 20 meg and I haven't even done anything yet? and it was because my images were accumulating through the through each sheet that I created. So the horizontal, maybe we'll go 200 by 38. See if that looks a little better. It's readable. And I wonder, I don't have the copy up, so let's zoom back up on a little bit, pixelate it a little bit. I'm okay with that. And so the select, make sure I can get in there and select, and copy. Then coming back over to SolidWorks, oh, I need that file again. So one thing to watch out for too, if I open the recent, keep in mind this is still the sheet format. The SLD DRT and the DRW DRT are both template files. They're system files in the background. If you modify them and save them, anything that's in that modification that gets saved back to exists in that file from pretty much then on. So Control V, and I didn't do too bad. That looks reasonable for size. I have room for a couple more notes if I want to make it. The problem is going to be that any file name sheet that runs a little bit long, it's going to be into the logo. So we'll see what it does. That may be one we have to play with a little bit more. So drawing number, draw to, and then we have some more information in there. So that's probably not a perfect fit, but it'll give you the idea of how it was inserted and worked. So I think it's easier to do the copy and paste from the clipboard than it is to insert an object. So, all right, pause one more time so I can. All right, so on Canvas, you'll be able to go in and grab the sheet format, download that. At the very least, to your downloads file. That now includes the logo that we just popped in there. And I'm not going to worry about it on this one. I'll correct it after we go through this invention. So, again, company logo or address or contact information, anything like that you want to build in. We're just expanding out the title block a little bit more and going through. If you want to reuse this, the property of Mesa Community College, you can edit the sheet format by right-clicking and edit sheet format. When you double-click in here, if you want to put your name, these are not proprietary to that level, but it kind of comes down to if it becomes an argument, it's mine. No, not quite. Not quite that bad, but you're welcome to use it. So, all right. So we started off with that assembly drawing. These are the components. That's the stack up. Wanted to see some numbers, so we kind of put it in there, and that really is where we're beginning the stack up. So I know that I can do position, but again, I want to kind of push the positional tolerances out a little ways, so that we can cover the rest of these items before getting too far into it. So the one thing that we saw in our notes or in the description is that the feature being a surface, technically, as soon as I split that with the V, or if I end up making it a U shape, it doesn't matter. This is one surface, this is another surface. Those are two separate features. All right, so in that case, my designation for the 4-inch diameter really needs to include a note for 2 times. So 2 times, I can type it in, and it's going to pick up that designation. So the software really doesn't care; it sees it, says, I'm not worried about whatever edge I picked. If it modifies, if it updates, it's going to it's still going to be 4 inches. It's just the clarification that both of those are being applied, and then it comes down to the datum V. Is it both, or do I apply it to one and then control the other one with it? I'm really not that concerned about it. If I maintain the circularity of 5 thousandths, maybe that becomes a times 2. All right, one of those gets the datum control, and then when we pick up the note, I'm going to work on the circularity. All right, so 5 thousandths, it can go 2.5 thousandths, which is to say that we can get just slightly elliptical, and it's still going to be acceptable. And we can vary that major and minor axis by the 2.5 thousandths. So to be able to see these, we're going to have to exaggerate our tolerances, probably from 5 thousandths up to 50 thousandths, and then we'll start to see the variation. If we go up to 100 thousandths, we'll really start to be able to see variation. But that's not a very practical tolerance, but for illustration purposes, I think we'll be able to pick those up. So my question was, which is, what am I probably going to manufacture? What am I going to locate on when I go to measure this center bore? And chances are the location, the feature that I'm going to pick, is going to be this outside diameter. And then whether it's as simple as, since this is a fairly open tolerance, all right, granted it's not that open, but I should be able to take a pair of calipers and measure from the hub to the rim, and very quickly get an inspection that says, yeah, I'm in that tolerance zone. So in that case, I'm going to stay with the B datum on the outside. And if I were to locate this on a V block or locate it on some type of fixture, then this would be my locating surface, and I would be measuring on the inside surface. Right? But again, I can't drive the inspection method. I just have to make the tolerances clear enough, make the datums and the control frames clear enough that whoever is doing the inspection can verify those dimensions. So I'm thinking about how I would do it, and that puts it in the mindset of, is this going to be a valid stack up? All right, so I called out perpendicular of 5 thousandths and concentricity or coaxiality of 5 thousandths. All right, so if you've heard either one of those terminologies, they're basically the same thing. So that 5 thousandths is also a 2.5 thousandths on this side, or if you're looking at just strictly the axis, how can that axis move perpendicular or shift within the circular object that we've called datum B. And then we did the thickness, and I'm not entirely sure that needs to be a basic dimension, but we are kind of controlling it. So we didn't get too far into regardless of feature size, and I didn't see it in my definition, but if it is not otherwise called out, maybe I did. Anyway, if it's not otherwise called out, the assumption is regardless of feature size. If you want maximum material condition, you have to call it out. If you want least material condition, you have to put the call out on. All right, so regardless of feature size, it's 210 thousandths thick, and the form control of flatness does not get a datum or get a modifier. It becomes the datum, and then other things are modified in relation to it. So we could look at modifying the parallelism, right, to maximum material condition, but regardless of feature size tends to indicate that this better be pretty darn flat if it's at 210. All right, if we're in that waviness or surface control that we're outside of the 2000s parallelism, then our stack up is going to have to be around 208. And then if we're also considering the other surface, now we're at plus or minus 5, I've used up every bit of that tolerance. So where is the crossover point for those items? So that's another one I want to take a look. We'll do a larger, maybe this will be a 2-inch part or something that we can do, again, 50 thousandths or 100 thousandths tolerance zones to exaggerate and explore. So our first pass is just what are realistic tolerances, or what are our tolerances that I need for this part, so that hopefully when this is on the machine and I'm making these, I can get you some good video and say, to hold this is what I did. And here's a manufacturing process that as a machinist, when I looked at the print and what I know about this part, this is the way I created it because. All right, so we come over to the plates, And the plates, these 5 holes, these lend themselves very quickly to positional tolerances. So my first pass through to get tolerance or get dimensions on this is just going to be to set some linear dimensions and get us into that orientation. So one of the things that I do pretty regularly is I won't put hidden lines in unless they show me something. All right, so again, that is a personal preference of mine. You know, seeing the dashed lines for those aren't really helping me. Right, so and if anything, they confuse the point. So that becomes a company decision or a company standard, and since I'm the company, that was my decision. All right, so you know, I want to improve readability. So that's my justification. Is I think it's more readable, and it does not add any great benefit to have a series of hidden lines over here when I can see the holes plain. If these were shallow spot faces and holes that I wanted to get in detail, all right, then I would switch over and we can go over to the properties for that view, since this is more likely the parent view. And I can tell it's the parent view because, well, it doesn't have a use parent view under the scale. It is using the sheet scale. And then I bypassed it. So if I were to do hidden lines visible, then this one doesn't have the use parent style. All right, so it depends on how we brought that in, but those 6 little lines, your call. When you're designing, detailing it, you make the call. All right, so if they add benefit and you want, the one thing that I always come back to is solid, really. You know, when ink's $1,000 a gallon, I'm not providing, you know, these solid blocks if I can all but help it. All right, so that should really detail something that, you know, this is important or really needs to be solid. Otherwise, I'm not filling any of that in. All right, so this is the clearance hole side. So let's just take a linear pass on these so that we can go through them. And this will be our first level. As we, you know, again, move into the next level, it'll be to apply more GD&T. What are my critical dimensions? What am I thinking of in the stack up? And, you know, what I'm saying is I want to give us a little time before we get into the positionals and start to see what, you know, we can develop as how this can move. All right, so my smart dimension, I am still down here somewhere in the dim layer. And so when I place a smart dimension, I can do whatever is readable. So the question is, when I put this, if I'm doing this on the machine or manual, where is my XY location? Well, for the designer detailer, I don't really get to decide, but if I can help out a little bit, or if I can help myself out if I'm making a part, I'm probably going to make this the fixed jaw of the vise, and this corner will be where the stop is. Right, so if I dimension in that relation, then I have those values. Once I make this decision, it is going to carry over to sheet 4, the other one, because mainly this is the other, you know, flatness call out is going to be on one of these faces. Right, so depending on how these assemble, and I start to choose those datums for a positional call out, then I'm going to become more critical. All right, so let's see, that did not make it to, so I can select, control select, and these are minor nuanced details. I can switch those over from the property manager for the center mark into center dimensions, and that helps me to identify. So my smart dimension then, and you know, is it apparent that those are 90 degrees and in line? Probably not. So even though I want to, you know, not clutter up the drawing, oops, oh well, I already did that. So even though I'm not cluttering up the drawing, I'm going to have to go to the top and bring that dimension through the other center line to designate without calling out it 2 times. And then coming off of dimension again, off of the same edge, through the part, coming back over, and we're in ANSI, so we get those, so I have to do a little maneuvering. Let's see if I can find a spot where that looks readable, and I'll go ahead and put the dimension in for the thickness. All right. For my hole callouts then, we have up at the top, depending on how these were created, I'm going to have the mix. Since these were probably just the circles, I don't remember how I did that, I get 190 through. Since it's not part of an instance count for the hole wizard, then I'm not going to see the 4 times. All right, so we're going to see a little bit different when we go to the next part that is a hole wizard. So if I want to control that, I have to put it in 4 times. And yes, I am manually altering it, and no, I'm not writing into anything else. So, all right, and then the last one, the whole call out for the center, 375 through. All right, so basic dimensioning strategy, linear plus minus dimensions. Nothing really really fancy. Can do a little cleanup. And the intent is that we will get this to a stage that next week we can start looking at those tolerances, that we overlap these parts and start looking at how that rectangular, that square tolerance is affected versus the circular positional tolerance. All right, so let's delete that one out. I don't want the note. I'm going to go to the whole call out, and since I brought it up, I'm going to show you the difference. All right, so since this was a hole wizard item, it has the quantity, it has the tap drill size, and it has the call out for the tap. And all that's included because of the way that it was generated in the part. All right, so these are basically symmetrical. If these were not symmetrical parts, I would be more concerned about the datum. But at least one side is going to be flat. I'm not overly concerned about parallelism. So when we get to that stage, building up to the next level, then I would work into those. All right, so I need to pick up the center marks. And clean those up. And then we'll go to the dimensions for the positions. Oh, got an angle there. That wasn't what I wanted. All right, so these aren't, oh, and then did I miss that one? Yeah, I pretty much missed that one, so we'll have to go back and get that one too. All right, so all off the same edge. And we'll get those in position, do a little cleanup as we go. Okay, and then the next one. So those I did not grab. So if I go to the extension line, I should be able to grab the handle and drag it to the next point. That didn't leave me a lot of gap, but that can be corrected. All right, and then same thing, I'm dragging to the next point. And if this fights me too much, I'm just going to delete the dimension and reapply it. Well, like that. So missed, that went to the min. Okay, I lost something there. and that's why it's probably easier just to delete it and reapply it than it is to move it. All right, so basically the same thing. I did not we can do the whole call out or dimension. And place our piece. So when we set this up to be the carrier for the bearing, these are going to have to be a little bit tighter than 375. But I want to look at the manufacturing. I said I was considering putting a shoulder screw in there. I may just take a piece of stainless steel and make another little round piece with a threaded hole that I can capture those parts with. All right. So the last one is the spacer. And so if I were to just put the dimensions on this, with the with all the linear, that gets us to the next level. All right, so I'm already planning on modifications and revisions. So one of the things, since the turnbuckle concept, the attachment point really didn't work out, this is probably going to end up with 4 slots to catch a carabiner or one of those threaded pieces, the threaded connectors. All right, so future project. This is enough to keep you entertained for tonight. We're going to build in these linear dimensions, and to look at the progression. If these need to go over to basic dimensions, we're talking about something that's relatively simple. Of if I decide that I need it, I come over here and I say this is a basic dimension. It ends up with the block, with the rectangular box around it, and now it's a basic dimension. But if I'm not applying a feature control, something to that dimension, it's really not helping me any. All right, we're going to call that good for tonight, and we'll work on it in lab.